All right, so we're looking for a value of x that will make y equal to -4. Does anyone think that they got it? Brandon? -2, okay? So let's check it out. So y equals -2 squared. What's -2 squared? So y would equal 4. So that one did not work, right? Because we need y to be equal to -4. What else, Ronnie? Ah, is there a number that when you square it, you'll get -4? Yeah. Now, let's talk about why not. Daniel, what's up?
Couldn't it be like 1 over 2?
Squared? What's 1 over 2 times 1 over 2?
Wait, no, never mind.
1
over -2?
1 over -2? What's 1 over -2 times 1 over -2? 1 over 4, right?
Okay, never mind.
Do you see how we're running into an issue? Why are we running into a problem? Zach? Very good. Whenever you multiply something by itself, there's no way you can get a negative result. So this is actually impossible. And let's write why. Does impossible have 2 S's?
Yeah.
Yeah? Okay. It's impossible because when you square a number, it is always positive. Okay? So in order for y to be equal to a negative number, that is impossible. Okay? Impossible. All right. Now, last week we went over f of x equals a times x squared. Okay? Now, that looks a little funky, so I want you guys to rewrite it. We're also going to be looking at y equals a times x squared like this. Okay? And we call this a quadratic function. Anything with a 2 as its exponent for the variable is considered a quadratic function, okay? Now, the quadratic function, or a quadratic function when you're looking at it, is normally defined as y equals ax squared plus bx plus c. Do you guys remember when we were factoring, we had the a, b, and c? Do you guys remember that? So, do you guys remember, like, a was the first coefficient, b was the second one, and c was the third? Okay? This is the generic format for the quadratic function, okay? But in the examples that we're looking at today, b is going to be 0 and c is going to be 0. So all we're left with is y equals ax squared. Got it? Okay. So when we graph this, okay, we get something called a parabola. Underline that word and write that this is the graph for quadratics. Okay? Anytime you have a quadratic function, your graph is going to be what we call a parabola. Now, it's a U-shaped function, okay? And there are some properties about that U, okay? All right, now, when you look down below, okay, this is what we call a parabola. Do you see how it kind of looks like a U? A little bit? Okay? Now, why do you think the graph goes down, hits 0, and then goes back up? Why do you think it's never negative? Brandon?
Because it's not equal to 0.
It is actually, it's going to be equal to 0. It will be equal to 0. But remember, this is y equals x squared. Why do you think this will never be negative? Daniel?
Because when you square something, it always has to be positive.
Very good. So our graph is going to get really close. It's going to get to 0, right? But it will never go negative because just like how we did in the warm-up, right? There was no value of y or x that would make y equal to -4. Do you guys remember that? So same thing applies here. We're never going to go below 0 on our graph, okay? All right, so there are a few definitions that you guys need to know in regards to this graph, okay? The first one is that this point at the very bottom of your graph, it's considered the lowest or the highest point. We call that your vertex, okay? Go ahead and highlight that and highlight the word vertex. That is the lowest point on your graph, okay? For the function f of x equals x squared, it will be at the point 0, 0. The second thing you need to notice is this dotted line going down the middle of our graph is called the axis of symmetry. It's called the axis of symmetry. Why do you think this is called the axis of symmetry? Brandon?
Just down the middle of the line of symmetry.
Yeah, it's symmetric, right? So the left-hand side is exactly symmetric to the right-hand side. Do you guys see that? Almost like a butterfly, right? A butterfly, when it opens its wings, it has the same design on the left as it does on the right wing. Do you guys understand that? That's symmetry, right? Do you see how this graph is symmetrical on both sides? Now, one thing to notice is your axis of symmetry will always go through the vertex. Okay? And the last thing that you guys need to know is that there's a portion of your graph where it's going to be decreasing, and there's a portion of your graph that is going to be increasing, okay? The red portion of this graph is the decreasing portion, and the blue portion is the increasing portion, okay? So as we move from left to right, do you see how our graph is going down? Our y values are decreasing. As we move from left to right, do you see how it's going in this direction? It's going down. And then as soon as we hit past the vertex, what starts to happen? It starts to go up, right? So in a parabola, you're going to have half of your graph is decreasing, half of your graph is increasing, okay?
I know you said
Yep.
it can't go negative, but can the parabola be under 0?
It can be, okay? It's going to be shifted around, and we'll see that, okay? This is specifically for the parent function, okay? All of your parabolas are going to have these properties, but they may look a little bit different depending on the transformations that were applied, okay? All right, so let's take a look at the next one, okay? So our vertex is at -1, -2. Do you see how it's no longer at 0, 0? Our graph was kind of shifted down into the left, okay? Your axis of symmetry still has to go through the vertex, so it's x equals -1. It's that vertical line, dotted line, going straight down the middle of the graph. Your function is decreasing on the left of the axis of symmetry, and it's increasing on the right of the axis of symmetry, okay? The only other thing that we need to notice is what our domain and our range are, okay? So write a D, write an R. Who thinks they know what the domain is of this function? Daniel?
All real numbers?
Excellent. All real numbers. Do you think it's going to be like that for all quadratic functions?
Yes.
Yes, okay? For domain, your domain will always be all real numbers for a quadratic function. You guys got that? Okay. What is the range, though? The range is not all real numbers. Bruno?
Y is greater than
-4?
Yeah.
You're close. Rocco?
Y is greater than or equal to -2.
Excellent. Greater than or equal to -2. Why, Rocco?
It's because Y can be on -2.
And it could be anything above.
Very good. Do you guys see how the graph exists for all the points above -2? Bruno, you see that now? Okay, so our graph is in this portion of, our graph exists in this portion of our y-axis, okay? It does not exist down here. Are we all in agreement? Okay, now, on your quiz, guys. All right, so in example B, what I want you to write is I want you to write over here on the right, we're going to identify the vertex, the axis of symmetry, we're going to identify the domain, the range, where the function is increasing, and where the function is decreasing. The up arrow indicates increasing, the down arrow indicates decreasing, okay? You may want to copy that and just paste it for the next example because we're going to label all 6 of those same things for the next one. Where is the vertex for example B. Shayla? 2 comma negative 3. Very good. Okay. It's at the bottom of your graph, at the lowest point, which is 2 comma negative 3. Okay. That is our vertex. Where is the axis of symmetry? Ronnie? Very good. At x equals 2. Draw a vertical line down x equals 2. It's when x equals 2. Now, you'll notice the vertex, the x-coordinate, is the same as the axis of symmetry. Do you guys see that? Yes? Okay. The domain. What is the domain of this function? All real numbers. What is the range of this function? Daniel?
Y is greater than or equal to negative 3.
Excellent. Y is bigger than or equal to negative 3. Why?
Because on the y-axis, it's down on negative 3, and it goes upwards.
Yep.
And it can be on negative 3 as well.
Excellent. Okay. It exists at negative 3 and it's all the values bigger. Where's the function increasing? Okay. Now, on this left-hand side, is my function increasing or decreasing as we move from left to right? It's decreasing, right? And these values are when x is smaller than what value? 2. Okay? Do you guys see how these values exist when x is smaller than 2, or my function is decreasing? Then when my graph is increasing, it's when x is bigger than 2. Okay? So on the left-hand side of your axis of symmetry, your function is either going to be increasing or decreasing. And on the right-hand side of your axis of symmetry, your function is either going to be increasing or decreasing. Okay? So, do you guys see the change that happens? As we move from left to right, do you see how my function is going down? That's decreasing, so it has to be x is less than 2. And then when x is bigger than 2, do you see how my function is going up? So that's when x is greater than 2. Let's do another one, okay? All right. In the next one, in C, what's different about this one? It's upside down, okay? But it has the same exact property, so we're going to be able to label everything, okay? Where is the vertex for this function? Brandon? Negative 3 comma 7. Very good. Negative 3 comma 7. How many people saw that before we went over it? You guys could have gotten that before we did it? Okay, excellent. Where's the axis of symmetry? Janessa? Very good. When x is equal to negative 3. You guys, why is it x equals and not y equals? The line is? What do we call something that goes up and down?
Horizontal.
No. Vertical, okay? Vertical lines are x equals a number, right? Horizontal lines are y equals a number, okay? So vertical means it's x equals negative 3. What's the domain? It's all real numbers. What's the range? Cody?
Y is less than or equal to 7.
Y is less than or equal to 7. Very good. Where is the function increasing? Janessa? When x is greater than negative 3. So that means that in this region, our function should be increasing.
When x is less than negative 3?
That means that our function should be going up on this side. I agree with that, okay? So I think we need to change it. When x is smaller than negative 3, right, to the left of the axis of symmetry, do you agree that our function is going up? And then once we pass the axis of symmetry, do you see how it's going down then afterwards? Okay? You guys, I'm not gonna lie, this is the hardest one, okay? Is where is the function increasing and where is the function decreasing? But when x is bigger than negative 3, our function starts to decrease. Brandon, what's up?
For the vertex, is the area of symmetry always going to be the x factor?
Very good, okay? because the axis of symmetry will always go through the vertex, okay? Questions?
For like all real numbers with the sine, like function that's going up, is it always both gonna be the same, like the same way?
What do you mean?
Because on like both of them, they both have the same way, like less or greater. Like on this one, it's both less, and on the last one, it's both greater.
Oh, for range versus function increasing? Yes. Mm-hmm. Yep. I didn't even notice that. Yeah, that's a good point. What else, guys? Any other questions? Okay, so the only other thing, oh, we are back one slide. I forgot to talk about this. Okay, so remember, we're dealing with a values, right? Because it's a times x squared, okay? When a is bigger than 0, we get parabolas that look like this, okay? Now, when a is bigger than 1, that means you are going to be vertically stretching your graph. It's going to be like nice and narrow. Do you guys remember what we called, like, what do we call a stretch of a graph? It falls under the category of what?
Oh, inside parentheses?
Kind
Wait,
of.
No.
What do we call all that stuff? Starts with a T. Transformations, okay? Do you guys remember the transformations? Okay, so when we multiplied by a value, right? When we multiplied by a is bigger than 1, that was a vertical stretch. Do you guys remember that?
Yeah.
And then when a was between 0 and 1, it shrunk our graph. Do you guys remember that? Okay, same thing applies to a parabola, okay? So when a is equal to 1, we call that our parent function. That's our basic function, right? The blue one. When it's, the green graph is when a is bigger than 1. Do you see how it kind of like stretched it out vertically? Kind of made it nice and skinny? And then when a was between 0 and 1, it shrunk it and made it smaller, okay? Now, you guys are not going to have to remember what they're doing because you're going to be able to calculate in a graph exactly what your points are, okay? What would cause the graph to flip upside down? If it was negative, okay? This is when a is a negative value. So if a is less than 0, your graph is going to be upside down, okay? And we know that because what is a negative as a transformation? What kind of transformation is a negative or a negative sign? Yep. It's a reflection. Very good, okay? So we're going to be reflecting it over the x-axis, all right? Yeah. Yes. Okay, so what you guys need to know how to do to graph our own parabolas, okay? So take a look down below. Oh, actually, is when you're graphing these, okay, you're going to have to create a chart, and you're going to have to graph 5 points, okay? Looking at this function, okay, f of x equals 2 times x squared. What is my a value?
2.
It's 2, okay? That means, are we going to vertically stretch or shrink my graph?
Stretch.
Good. It's going to be a vertical stretch. By what factor?
2.
Good. It's going to be a vertical stretch by 2. Now, are you required to write this down? No. Okay, on your test or on your quiz. But it is helpful to know what it's going to look like before you start to like plot it, because then you'll be like, oh, it kind of matches what I thought it was going to look like. Yeah, Isa? Because it's just the number in front of x squared. Okay? It's the coefficient in front of x squared. All right, so when we're plugging in -2, watch carefully, guys. You're going to plug in f of -2, right? Because that's my x value, equals 2 times -2 squared. Do you guys see how wherever I saw an x before, what did I put to replace the x? -2. Why is it negative? Because those are just the values that we're going to test, okay? We could have tested other values, but that's the one that we picked, okay? I want you guys to circle this and write yourselves a note, because I see this happen all the time, okay? What do we do first here? Do we multiply the 2 and the -2, or do we square it? Isa? Why? Very good, okay? Excellent. You guys have to square first. Do you think you're going to get the same answer if you multiplied first? Absolutely not, okay? I see it happen all the time where people will multiply the 2 and the negative 2 and then square it. By PEMDAS, we have to use exponents. We have to take care of our exponents before we multiply anything. Are you guys cool with that? So, what is negative 2 squared? Nope. Positive 4, okay? So this is going to be 2 times positive 4, which is 8. Okay? So our first point is at negative 2 comma 8. Yes? Okay. My second point is going to be f of negative 1. So it's going to be 2 times negative 1 squared. What do I do for this one? Brandon? Okay, but make sure that you're squaring first. Yep. So negative 1 squared is 1. So this is going to be 2 times 1. And 2 times 1 is? 2. So my second point is what? Negative 1 comma 2. Excellent. Who can walk me through the third one when x is 0? Janessa?
So you replace the x with 0.
Yep.
So the f of 0 equals 2 times 0 squared.
Good.
And then you square 0 with x is 0. 2 times 0. And then your point would be 0 and 0.
0 comma 0. Excellent. Someone walk me through the first one. Very good, Janessa. Someone walk me through the third one, or the fourth one. Yeah, Isa?
So you plug in the 1, so it's f of 1.
Yep.
And then it's like 2 times 1 squared. And 1 squared equals 1. And 1 times 2 equals 2. So it'd be 1 comma 2.
Good. And the last one. Gabby. George.
So you replace the x with the 2,
Yep.
and 2 squared is 4, so it would be 2 times 4 is 8, so that's our
2 comma 8. Love it. Okay. How many points am I going to ask you for your graph? 5. Okay. Do we have 5 here? Yes. So we can go ahead and graph it. Okay. How would you graph negative 2 comma 8? How would I graph that? Brandon?
Negative 2 on the x-axis.
Good. Negative 2 on the x-axis and on the y. You should get a point up here. What would I do after that? Yeah, Brandon?
Negative 1 on the x.
Good. So that should give us a point here. Next after that, Ronnie?
It would be, you do 0.
Yep. 0 comma 0. After that, Cody K?
You would put the other dot on 1 column 2.
Good. And where's my last one going? Yep.
2 comma 8.
2 comma 8. So once you have all 5 dots on there, okay, you're going to notice, what is this going to look like when I draw a line or a curve connecting all of them? Yeah? Yes, it is, okay? Do you guys see how it's a parabola, first off? Do you guys see how our shape is like a U? And is it skinnier than our normal one, or is it wider than our normal one? Skinnier. And it's skinnier because we stretched it vertically, right? By 2. So it should be a skinnier graph than our normal one, okay? Are we all okay with that one? Brandon, what's up? And I'm going to be honest, guys, we weren't doing so hot with the increasing versus decreasing. Let's try to do it for this one. So where is this function increasing? Where's this function increasing? Brandon? Good. When x is bigger than 0. And where is this function decreasing?
X is less than 0.
When x is less than 0. Do you guys see that? Because to the left of my, where's my axis of symmetry?
Is it just like the 0 is just where the vertex is?
Yeah. So 0 is where the vertex is, right? And the axis of symmetry is right down here, right? Do you guys agree with that? So do you see how on this side, when x is smaller than 0, my graph is going down? And when I go to the right of 0, my graph is going up. So my function is increasing when x is bigger than 0, but my function is decreasing when x is less than 0. Do we see that? Yes? Okay. All right. Good. Let's go ahead and do the next one. We've got 5x squared. Now, again, you don't have to do this on your quiz, but let's do it for our sake. What is a here? A is 5, and that means what kind of transformation is going on? Brandon? Good. It's a vertical stretch by 5. Okay, so we've got x and we've got g of x equals 5x. What do I do for the first one? When x is equal to -2. Gabby? Good.
And then -2 squared is 4. So then you write 5 times 4, which is 20.
Good. I love how you squared the -2 first. So 5 times 4 gives me 20. Okay? -2 comma 20. Beautiful. Okay? Someone do the next one. Daniel, go for it.
G of -1 equals 5 times 1 equals 5.
Oh. So you squared it already?
Yeah.
5 times 1, yes, which equals 5. So what's my point?
It's -1, 5.
Good. Who can do the third one for me? 0. Brandon?
You square the 0, so it's 0, 5 times 0.
Good. 5 times 0 squared is going to give me 5 times 0, which is 0. So 0 comma 0. Doug, you do the next one?
Okay, so you're doing 5 times 1 to the second, so it's 1 to the second, so it would be 2. So you do 5 times 2 equals x.
Ooh, hold on.
Oh, wait.
1 to the second is 1 times
Oh,
1,
no,
right?
yeah, it's just 1.
It's just 1, yep.
So you can just get 1 to the 5th.
Or 1 times 5, which is?
Yeah.
5, right?
5, yeah.
Okay, so what's my point?
1 to the 5th.
1 comma 5. Excellent. Okay. All right, next one. Janessa.
Replace the x for 2, so you're gonna do g 2.
Yep.
And then equals 5, parentheses 2 squared.
Good.
Then you're gonna have 5 times 4. And you're gonna have 2 comma 20.
2 comma 20. All right, guys. 2 of these points will not fit on my graph. Which 2 will not fit? Brandon?
-2, 20, and 2.
Why won't those fit?
Because it goes to 12.
Yeah, our graph only goes up to 12, okay? So I expect all the points that fit to go on your graph. Got it? Okay? So -2 and 20 and 2 comma 20 we can ignore because those don't fit. So we're going to put -1 comma 5. We're going to put 0, 0, and we're going to put 1 comma 5. And then we're going to draw a nice parabola. Yours is probably going to look better than mine. Okay. Once you've drawn your parabola, okay, I want you to compare this parabola to the parabola before. And what do you notice? What's different about the two parabolas? Brandon?
It's skinnier.
It's a lot skinnier. Yeah, very good. Why do you think this second parabola is even skinnier than the first one we did? Isa?
Because like the first one, it was stretched by 2, and this one's stretched by 9.
Good. We stretched it by a greater factor. That's excellent, okay? So when we're stretching by like 11, it's going to be even skinnier than this. Like when you stretch by a factor of 2, you're stretching it like a little bit, right? When you stretch by 5, you're stretching it by a lot. And if you stretch by like 100, it's going to be like super duper skinny, okay? Do you guys see that? Okay, so anytime you're stretching by a bigger factor, it's just going to be a skinnier graph, okay? Any questions on this one? Brandon, what's up?
On the quiz, do you make this stretch it out by more than 10?
Maybe. Yeah.
On the quiz, we're gonna have to do all the 6 things as well as the graphing it too, right?
Yeah, but not. Let's keep going, peeps. We've got 2 more to do, okay? P of x equals -3 times x squared. What's a, peeps? A is equal to -3. So there's actually two transformations here. What is one of them? Janessa?
Oh, shrink.
You think it's a shrink?
Well, first a reflection.
Ah, there's a vertical reflection. So that takes care of our negative, right? What is the 3 going to do? Isa? It's still a vertical stretch, okay? What would a shrink be? Good, 1/3, okay? This is a vertical stretch by 3, okay? And it's a reflection. So, do you guys remember how we had a U shape before? It's going to be like an N now. Remember? Our graph is going to get reflected, so it's going to be like, it's going to be flipped. It's going to be upside down. Another person. Okay? All right, so check it out. When x is -2, what do I do? Brandon.
Square the -2, so it'll be +4 times -3, and it'll be -4.
Excellent. It's going to be -3 times -2 squared, which is -3 times +4, which is -12. What's my point, Brandon?
-2, -12.
Good. All right, what's next? Veronica, go for it. Yep. Yep. Mm-hmm. Good. -1, comma -3. Excellent. Bryson, do the third one.
It'd be P and then 0 in the parentheses.
Yep.
Equals -3 and 0 to the second power.
Yep.
And then it'd be -3 times 0
Yep.
equals 0. So it'd be 0 and 0.
0, comma 0. Chloe, do the next one.
Replace x with 1.
Mm-hmm.
And then you'd square 1, which would just be 1. And then multiply it, so it'd be -3 times 1, which is -3.
Excellent.
So 1 comma -3.
Beautiful. And Sophia, do the last one.
Last one is gonna be P, and in the parentheses you're gonna put 2.
Yep.
It's gonna equal -3 in parentheses 2 to the power of 2.
Yep.
That's gonna give you -3 times 4, and that's gonna equal -12.
Perfect.
And the it's gonna be 2 comma -12.
2 comma -12. Okay. So anytime we have a quadratic, right? That's with the variable squared. Our graph is going to be what shape? Parabola, right? You have to know that, okay? The parabola is that U shape. Now, ours is going to look a little bit different because we flipped it, right? It's going to be upside down. So, let's go ahead and graph this. -2 comma -12 is down here. -1 comma -3 is right here. 0 comma 0 is right here. 1 comma -3 is right here. And 2 comma -12 is all the way down here. Do you guys see how this not only was stretched vertically, it's nice and skinny, okay, went on a diet, but it also flipped itself upside down? Yes? We see the difference between this one and the two that we did before? Okay. Daniel, what's up?
Technically, since you know the h of x, or wait, the p of x is always going to be just the same, 0, and the same. Can't you just do the first two and then you'll know the rest?
Yes.
Okay. So you have to do all the work.
Yeah, I would appreciate if you did all the work though. Okay? But that is good to notice. So what Daniel's saying is these values are going to get repeated down here. Do you guys see that? And 0, 0, we call that what? It's the vertex, okay? Because that's where it changes direction, okay? Yes.
Oh, where would the increase and decrease be?
Ah, where would the increase and decrease be? Well, let's take a look. Where is my function increasing? Cody?
X is less than 0.
Very good. So our function is increasing when x is less than 0. Do you guys see that? Because it's going up on this side. Where is it decreasing? Janessa?
Oh, wait, no, I have a question.
Brandon? Oh my gosh. Can someone answer my question? Cody? When x is greater than 0, our function is going down. Yes? Janessa, what's up?
Where you supposed to put it at -3? Your points are at -4.
Which points?
The 2 points on the graph.
Did I not put it at -3?
Oh, no, maybe you were supposed to. Never mind.
Adam, you good on that? With function increasing, decreasing? Okay. Any other questions, peeps? One more, and then we're done. Okay, bear with me. Come on, wake up, people. All right, let's do it. So the next one that we're going to do, okay, why is this one a little bit different? Ronnie? It's a shrink. Why is this a shrink? It's less than 1, okay? Now, the negative means we're going to do what? So A equals -1/3. There's going to be 2 transformations. One of them is a reflection, and the other one is a vertical shrink. Okay? All right. Now, take a look at the x values that they plugged in. Why do you think that they're plugging in? They're no longer plugging in -2, -1, 0, 1, and 2. Why would it be more convenient to plug in 9, -9, -3, 0, 3, and 9? Dougie?
Because 3 squared makes 9 and they go together.
Good. They're using multiples of the denominator, okay? So I want you guys to write a little note to yourselves. They use, because you're not going to get this chart, right? You're going to have to create it on your own. So use multiples of the denominator. You guys got that? How many x values will you need? 5, okay? You're going to need 5 points. They may not all fit on your graph, but you're going to need to calculate 5 points. Got it? Okay, so let's plug in -9. Who can plug in -9 for me? Tell me what to do. Daniel.
Alright, n of -9 equals -1/3 times 81
Yep, because it's -9 squared.
equals -27.
Good. -27. And what's the point then?
-2, -27.
Close.
Or wait, no.
What did we plug in for x?
-9, -27.
There we go. -9, comma, -27. Okay, very good. All right, who can do the next one for me? -3.
Wait, how is it 27?
81 divided by 3. Who can do the next one? Come on. Bryson, go for it.
It'd be n and then -3 equals -1/3 and -3 in the parentheses to the second power, and then it'd be -1/3 times 9,
Yep.
and that equals -3.
Good. So my next point is -3, comma.
Oh, -3 comma -3.
Excellent. Alexandra, can you do 0 for me?
And equals, replace x with a 0.
Yep.
And then you square, which is just going to be 0, and then you multiply it with 2/3, it's just going to be 0.
Good. Okay. This is going to be -1/3 times 0 equals 0. So 0, comma 0. Do you guys notice when we're dealing with the a times x squared, right? When we're dealing with that quadratic, 0, 0 is always going to be our vertex, okay? In 8.2, our vertex is going to move around, okay? But for all of these examples where a is just a times x squared, it's going to be 0, 0 as our vertex, okay? Who can do 3 for me? Cody.
Okay, so
Good.
And then 3 to the second is 9.
Mm-hmm.
And then so you do negative 1/3 times 9, which is 3.
Good.
And 3 comma 3.
3 comma negative 3. Very good. Okay, and the last one. What's the point? Negative 27. Okay, let's do it. It'll be h of 9, which is negative 1/3, times 9 squared, which is negative 1/3, times 81, which is negative 27. Beautiful. Which 2 points are not going to fit on my simple graph? The negative 27s, right? Shayla, graph the other 3. Good. What kind of shape is it going to be? An upside down U, yep. How would you describe this graph compared to the other ones? It's fat, right? Kind of got carried away for Thanksgiving dinner, right? Gained a few pounds, all right? We basically shrunk it vertically, right? We kind of smushed it down. Do you guys see the difference there? Okay? I know it's not required, right? But you guys should be looking for that stuff before you do the problem. Because if you graphed it and you got a really skinny one, you know you messed up, right? Because you were supposed to shrink this vertically, okay? Any questions? Yeah, Veronica? You could do that, but your answers would be fractions. And I wanted it, in order for everything to be divisible by 3, I used multiples of the denominator. So that's why I used negative 9, negative 3, 0, 3, and 9, okay? All right, turn these in.